Okay, so I think we all agree that part A of this question is pretty easy. Well, most of us anyway. It might be easier to just factorize out the minus, so you know exactly what the center points are. So from that we get our points of intersection, 4, 5 and 4, minus 1. If we look at the graph, they're going to be here. So this is going to be our 4, 5, and this is our 4, minus 1. Okay, so now let's look at part B. So the argument of z3 plus 3 plus 2i is theta, and it passes through one of the coordinates of the intersection. So let's see if we're going to pass through here, or let's see if we're going to pass through here. So I'm just going to write this out at the top. So we want the argument of z3 plus 3 plus 2i, and that equals theta. But 3 plus 2i is a complex number, and this is going to be a locus type question. So let me actually get rid of that. And that's the same as saying minus 3 minus 2i. So I'm just going to plot that point here, minus 3, minus 2. So for this question, we want to find the values of z3. So what's important to know is complex numbers can either act as points or they can act as vectors. So for instance, let's say I have 1 plus I, and now I want to add 2 plus 3i onto that. Well, that's just going to give me 3 plus 4i. Now what this represents geometrically is we start at this point, we added on this point, and we ended up here. Now this is something similar, except the question asks for the values of z3 at the points of intersection. So if we look at this, we're actually starting at this position, minus 3 minus 2i. So this here is going to represent our locus, which is going to be a straight line. So we're starting off at minus 3 minus 2, and we want to go through either 4, 5 or 4 minus 1. So these are our two possible loci. Now our z3 represents the vector that can get us from this point onto a point on this line. So for instance, we could go along 3 and up 3, and the vector that lands us on this point here is 3 plus 3i. So that there is our value of z3 that takes us to 0, 1. But of course, we don't want to go to 0, 1, we want to go to one of these points. So to get to 4, 5, we can go up 7 and along 7. So the vector that takes us there is 7 plus 7i. So this is our z3 for this point. The other way is we can go along 7 and we can go up 1. Now this vector here is 7 plus I. That's our value of z3 there. So now we have our two z3 values. What we want is we want to express it in this form here. R equals e to the I theta. So we need to find the modulus and the arguments. I think maybe another good way of understanding what this actually means is perhaps thinking of it in vector form. So we have minus 3, minus 2, so that's our starting position. And then we're adding on lambda lots of the direction vector. And in this case, we had two possible options, 7, 7, that was to get us to 4, 5, and 3 minus 2 plus, I'll just put mu, 7, 1, that will get us to 4, 3.
Hey pal. You just blowing from stupid town?
Now of course in this case, to get us to 4, 5, lambda had to be equal to 1 and mu here is equal to 1. So if mu was equal to 2 for instance, well that would just represent us going along further to a different point on this locus. And of course if I'm going to highlight it, these are our direction vectors which will represent our z3, and we're starting off from this point, and if we take that route we end up at either here or here. And finally for part C, the argument of so we had 0.14 or we had pi over 4 for our two arguments. Now obviously this is less and this is going to be more, so we only focus on that. Well, from the graph we can clearly see that it's just 2, 3. So this right here is the answer to part C.